It is an honor to invite Dr. Rajesh Gokhale, Secretary, Department of Biotechnology, Government of India, to deliver the first keynote.
It's just easy to move around and then talk rather than standing at one place for a professors like me who are used to moving around and not just staying at one place. But namaskar and a good afternoon to all of you, and thank you very much for inviting me over here with this lovely campus and lovely settings. YIM is not new to me. I call it YIM, YIM, so YIM, whatever. And I've been here as a faculty, as a director of an institution, as a mentor, but this is the first time I'm coming in person as a DBT secretary, actually. And it's such a pleasure to be over here. Of course, I've known Shashi over the years, and some fantastic things we have done. And Symbiosis campus, I have been here earlier to see some really fascinating journey that they're going through. And I think it's an amazing opportunity for the country to really realize the potential of what we have. And my prime reason was to come to give you the perception of how, if I just wish I was 25 today. The world is so much more amazing to do and achieve things that you cannot even imagine. You could only dream about doing impactful science. I think this is an opportunity for you to do impactful science. It's not just an opportunity to do science. All of us dream and come to PhD programs for doing impactful science, and this is the opportunity of life, particularly in biotech system, to cross disciplinary areas to be able to make it happen. And therefore, what I put my title of my talk is "The Future Belongs to the Bold," actually. And when I mean by bold, it's at individual level, institution level, and also at the level of government. Every country you can imagine has completely different ways of looking at how they will grow and become accepted in the world. Similarly, the institutions as well, and so does individuals, actually. And one needs to integrate these parameters to make sure that you reach a successful journey. And therefore, first of all, to congratulate each one of you for taking up this career path. You are on the right path of your life. I can tell you that. And these variety of flavors is what we all want. And the leaderships, clearly. One of the things that I have realized being in part of Department of Biotechnology as of now today is one of the real challenges to find good leader in our country right now. And it's probably the way we have been grown up in the system. It's not little bit harder to find very good leaders, but this is what it is. I think this is wonderful. As I would think, you had this wonderful picture here, which is a beautifully encaptures what I really want to talk about, is how by fueled by bold and innovative thinking can create unstoppable impact. And this can happen in such a short period of time that many of us will doubt our own thought process. And really, when they unite, they turn challenges into change and shape a better future. And I think I congratulate all of you for putting this as a symbol for your India Bioscience EM sessions, actually. So let me try and give you a perspective of how do we really look at historical perspective and how do we really see future of our world. And that's the kind of ways that people starting their careers now would want to understand this. This is about 300 years of what centuric development I put together as an x-axis. And you see what on the y-axis is really GDP per capita, which is calculated in 2011. And what this tells you is that when the technological revolutions come, they change everything. Whether it's air, water, weather, your life, your processes, everything gets impacted, and it's irreversible. You all should remember this. It's irreversible changes. For example, if you really look at what has happened in the 1750, the industrial revolution that started in UK, and it started by basically making cloth using willing spinneys we used to call, actually, and they used to started needing cotton through a mechanization ways. And then the age of railway came, then the age of heavy engineering, automobile production, mass production, chemical industries. And this is the technological breakthroughs that many of us have seen called ICT. And I personally put it this that next 25 years is going to be biomanufacturing. As Dr. Vidya and Dr. Shashi mentioned, how you can utilize the power of biology to really do the transformative stuff that what we want to look at, actually. So if you really look at the first part of the industrial revolution, mechanized the world. Imagine this. The second part electrified the world by having all these combination of activities. The third part digitalized, And the fourth part is going to be the biolization of the world. Every activity of human endeavors will get converted into biological systems actually. They'll be engineered by biological processes, they'll be driven by biological processes, and they'll be, shaped by the way these processes work. And that's why, I'm saying you're at the right time at right place, because this is what you want to lead India into actually. And this is a very, very competitive area. Every world is trying to look at how to be able to take to this actually. So let me before give you the perspective. The whole of the world was here recently in India for the AI Impact Summit. And I take the quote of Sam Altman. He was discussing at IIT Delhi with students and all, and just see what he said. I think listening to the old people is the biggest mistake young people make. And of course, this became a little bit more viral because of the kind of statements that he gave. But what it says is that for predicting what the world is going to be like going forward, I don't think you should trust me, but to have a good intuition about the rate of change. Young people always figure this out, and the world you are all inheriting is going to be very different. You'll have to quickly develop your own intuitions and trust them. But I think the traditional career advice is probably not going to work as well. And that's what I wanted to tell you actually, that many often we look at our past and think that's the future. Unfortunately, the word that he uses, rate of change. The rate of change that is going to come about in the world in the technological perspective is going to be quite remarkable and quite amazing actually. You can just really think about this. And the reason, therefore, what I'm trying to say is that in future, scientific careers will have to be nurtured by keeping in mind factors beyond individualism. And that's the key bottom line that I want to impact about. Because when I started my career, actually, I started what I wanted to do, and I wasn't advised by anybody what I should do. There was no YIMS and no mentorship, and I did not know mycobacterium tuberculosis, but I came and started on tuberculosis area on my own, figured out the path, and I thought I did some exciting science, made no impact on any clinical perspective by my fantastic papers and publications. Therefore, I decided to move into an area of leukoderma, vitiligo, and it's that's the way the journey is. And again, an area completely novice here, and hopefully, there is a student of mine has a company now in a phase 2 clinical trial that's ongoing. So hopefully, the molecule will emerge from there. And I think that's the kind of belief that you need to have, that you want to do science and technology that makes an impact. And even if in 25 years of your life and make one major impact, in 2000 when I started, today you have to do this in 10 years of time. And that's the real challenge that we look at. And I'm not going to read through this, but my slides are here. But really, team science over solo science is the real preferred model. The translation impact matter, the success matrices of all countries will contain technology deployment, startups, and polyfinance, and not just publication, not just India. Believe me, every country will remodel their whole models of successes. You can see what is happening in US, you can see what is happening in UK, you can see what is happening in Argentina, which is the worst of all actually. And then long-term programmatic thinking is absolutely must, and I'll give you a few examples of how it is. The digital and data literacy as a common layer. You cannot escape the digital and data literacy in today's environment. In fact, every student of mine first joins and learns how to do programming these days, because you can do this very, very quickly actually, right? You really give it to ChatGPT or Gemini, and they give out the codes to you. You really figure out, reassemble them together in a way that one has to look at, and the data has to be analyzed by my own self, because you're not going to be dependent on bioinformaticians, a class called bioinformatician, to provide you the information. They can do the deep stuff, but you cannot work on this actually. So many of these things are, all of you would know, but I'm actually saying that these will really be very, very transformative. But why I think this is likely to happen actually. So I want to show you 3 examples of biological revolutions that has already changed our country, just to emphasize the fact that what I'm saying is not untrue. It is really, in real sense, it is the most truthful stuff actually. And this is the first example. Many of you may not be there at this age, but at 1965, there was a food crisis with back-to-back monsoon failures in the country. 3 back-to-back monsoon failures. To an extent that our Prime Minister at that time, Lal Bahadur Shastri, said, don't have one meal at least a day. so that you can feed everybody. And he announced it on the radio at that time. And can you imagine from there, today, our country is a surplus food country, actually. Just imagine that. And this happened in 20, 25 years of time. So I call it, this is the first example of harnessing the power of living systems. You're using plants, you're using, how did the government do this actually? This really requires a system level thinking. And the way it happened is that development of high yielding varieties was not the only thing, but expansion of irrigation infrastructure, mechanization of agriculture, chemical fertilizers and pesticides, establishment of IARI system and seed technology and distribution. So you can imagine what I'm trying to tell you is that it appears that what we are talking today hasn't happened, but that's not really true. This is a first example that I'm showing you where system level thinking led to the self-sufficiency in grain production to an extent that we can now provide free grains to many countries actually, and we can have bargain. And why this is important, all of you realize this, because in the today's world of complex world where transactions are becoming extremely transactional, it's not that the transactions were not there, but transactionals are becoming extreme transactionals to an extent that people are asked to give away something to take something. And I think this was very, very important at that time. And I think an amazing journey, what we call green revolution of period of time. The second example, let me give you of milk shortage. Again, some of you who are not of my age would not recollect this, but some of you may know that India had a huge milk shortage in the country actually. You used to have to fight for getting one milk bottles, and some milk was not available, something was available. And I remember in Delhi, actually, in whosoever lived in Delhi, there used to be a Delhi milk scheme van used to come, and one booth you used to put somebody used to put the stone there for you to, saying this is my number, so that when the booth van will come, I can go and get a bottle of milk actually. And that's the kind of state. India today is the largest producer of milk. 20% of the world milks come from this country. 20% of the milk comes from this country, believe me. And this is again due to what is I call amazing system thinking and grassroots cooperation, which allowed this science to happen. Again, milk, you can imagine, is a biological product, and how biological products have continuously transformed the country. And this is what it has done actually. It's an aggregator model, correct? What is the model that works? And this is what I want as a scientific community to start thinking about, system level thinking of processes. You can do one part of it, but until unless you do the system level thinking, you cannot solve a complex challenge. You can say, oh, I have this and I have to find for this. Please find me buyer, please find me supplier, please find me circularity chain. That cannot happen. That is not any longer possible. It was required during those period because the knowledge was not accessible. But now the data science allows you to get an access to every part of knowledge. And what happened is the aggregator model actually. An aggregator model was that all the villages will get out the milk in a cooperative model, put the milk at one single place and will carry out this activity. And obviously, this worked model because it was collected at many places, forces were local and natural. One chilling center and one route serves thousands of stakeholders actually. However, not all models work in these kind of ways. I want to give you an example of this. So this model then was tested for grains. The cooperative society Amul that we all hear about, the aggregator model in fact failed. And the reason for this is because, for example, even it didn't work with the livestock as well. The payments are delayed, middlemen dominate, aggregation less compelling outside milk. Because milk is a perishable product, correct? Once the farmer takes it, if he does not sell it within the next couple of days, he has no value for it. And so for a perishable model, with one chiller set up around here and aggregating these contexts very well, how you are able to convert this. And that is where I say that the system level thinking has to come in, and therefore one needs to think about how it is actually to be done. The third example that I will try to give you is of biomanufacturing during COVID-19 pandemic. When I was a secretary at Government of India, and the first task that came about is that companies across the world was talking to India that we can give you maximum of 1 lakh vaccines. And if 1 lakh vaccines were given, the first question that, at the highest level, Honorable Prime Minister had, whom all we can give. And how do you distribute vaccine? Because the scenario was such that everybody required a vaccine. And we know it's a 1.4 billion people country, actually. So there'll be a tremendous amount of chaos, there'll be tremendous amount of challenges. And so what Honorable Prime Minister took this decision himself is that we will manufacture in our country, actually. We are not going to be dependent on other countries' world. We're never going to be dependent on this, and we can do this in a very short period of time. And therefore, I call this is another watershed moment. Again, amazing example of how biological processes can be scaled at an astonishing pace and time scales if we stay united and work together in the system. And you can imagine now in today's our country with Mission COVID Suraksha and various programs that government started, we now have a DNA vaccine, world first DNA vaccine manufacturer, protein subunit manufacturer, intranasal vaccine, inactivated viral vaccine, mRNA self-replicating vaccine, as well as various other programs. And we now have not just an R&D capacity, but entire manufacturing chain for every activity that is present in our country. And therefore, not once but thrice, life sciences and biotech systems have given amazing examples of how you can provide to this country. And therefore, we should never underestimate the level of scientific ingenuity and the technological prowess that our country possesses in terms of what it can deliver and what it can do. The other part that you must have realized that once India takes it up, like for example, you know how much India gave away 2 billion vaccines doses were created, right? Actually, and they were delivered with the certificate online now. And you can see now the next vaccination round, which has just started, HPV vaccination again, it's going to start. And every country understands the importance of Indian perspective of what we can do, when we are able to scale it up. So all of these, mind you, happened because of this one circle, which is natural intelligence. And this is a natural intelligence of human beings, which is an amazing capabilities of adaptive capabilities, as Shashi rightly said, evolutionary processes develop all these activities, is how all technological revolutions have occurred. But in the next few years, these are the two circles that are joining it together, actually. The one is a biological intelligence, and the other one is an artificial intelligence, actually. And the biological intelligence is encoded, structured, and maneuverable. You can manipulate this the way you like. And now it is feasible within months or within days rather than anything. And the algorithmic is an amplified human understanding. So together, in my opinion, this triad of intelligence is the transformative power of paradigms which will accelerate co-evolutionary processes at an unprecedented pace. At an unprecedented pace, believe me. By the time you think that I will start my career and start looking at this, somebody else would have done. And so you have to mandatorily work in a consortium mode if you want to develop something of beyond what your own single capacity is. And I can almost guarantee you, it will impact every individual career starting today. And that's where, whether it's in next generation advances in manufacturing of healthcare, agriculture, environment, or resilience, that's the only model that will work, actually. Just to give you how other systems, other countries are doing this, and I like giving examples because so as to give clear idea about what it is, actually. This is a paper about melanoma towards next quantum leap in melanoma. And you can imagine, many of you know this is one of the biggest problem in Caucasian population for melanomas, actually. I wanted to tell you, how does this work in the world, and how we are going to do in India is going to be very, very different, actually. And one of the reasons that I'll tell you is that what it takes to translate new products in West is you just see the authors' names are over here, and you look at their conflict of interest. This is the conflict of interest that's written over here, actually, for every author. And you look at the number of companies that they are advising, they're part of these activities, and they're amazing. And none of these companies are duplicately written, mind you, on this paper. So just imagine the level of activities. If you want to translate and come to India, which is what we're talking about today, can you replicate this model? How long will it take for us to replicate this model? It is absolutely impossible. And therefore, we need to become our own innovators of our own technological prowess, our own ways. Many of these drugs, what happens, are basically very expensive, primarily because of all these people being party to this actually. The cost of the drugs is unimaginatively and unaffordably high actually. This is not the way India is going to become Viksit Bharat. Indian model is social, and socio-economic models are the only model that works, and every country will follow Indian perspective. The UPI model that we have now come up with, as you can see now, Honorable Prime Minister said Israel is going to adopt the UPI model of governmental financial stack. Correct? There are no Visa players, there is no MasterCard, there is no other companies making money. It's the government who facilitates infrastructure and allows you to produce activities. And that's exactly the model that will work in our country. And that's why I wanted to showcase, if you come back from US or if you come back from another countries and think I can replicate what's going on, it's going to be next to impossible. You try to create so many things actually to be part of it. It is required. It is required, but it's not necessary. And it also leads to the cost of the production, because so many consultants, so many people providing all these consultancies is not the model that will work actually. So how do we really do this? And at Department of Biotechnology, I think in 3 layers that we work actually. And these 3 layers are, which I call 8 pillars of foundational elements, which forges collective intelligence and networking. And these are, the first is the knowledge layer, which is basically the technology, science and technology, innovation and infrastructure. And we work on each one of these. The second one is the translational layer, which is startup, financial models and partnerships, which is through BIRAC and various other ecosystem. And finally, the layer is of an outcome layer, which is of social impact and sustainability. And our model, therefore, is connecting science, scaling solutions, and transforming lives. And this is exactly what we are trying to do over the last 4 to 5 years, and in fact, several decades. And that's why Department of Biotechnology, even though such a small department, has such an enormous presence in the country, because it has wonderful leaderships over the years who have continued and maintained these activities and be futuristic. I call Department of Biotechnology the Department of bold technology actually, because and that's the way we have been working in the systems. And the reason why we cannot work in the isolated problem, because the problems are, if you optimize single component, it shifts the problem elsewhere actually. Like for example, if I only have high yielding crops, the groundwater and soil depletion actually becomes a challenge. How do I really solve the problem? Who is going to solve that problem? So your high yielding crops are not going to be high yielding crops. Similarly, you produce potent drugs using that model, you have unaffordable therapies. You have industrial efficiency, the carbon intensity will go up, and food production, the nutritional imbalance continues to grow actually. So how do we really build it, and how do you really ensure that many of these activities have to really go through the process? And therefore, the system level thinking in circular bioeconomy, which is a paradigm shift from component optimization to system level redesign, is what all of us need to do. And particularly, we need to become a component, but think of a system. And that's the model that we all need to work on. We cannot think that the one component I will develop and I will be helped by somebody else to optimize the second component. And I think these are the kind of real challenging times of we have. Either it's agri-food, energy, chemical, health, or climate change. And all of you know this, that anything that can be coded by DNA can be biomanufactured now. You don't necessarily have to worry about it. It can absolutely possible. Anything that's coded by DNA can be biomanufactured right now. And that's the kind of amazing capabilities that we've reached to a target for it actually. So how is that healthcare? I mean, how much time is there really? I don't know. I saw the clock. 18 minutes. Okay. All right. Thank you. I thought the clock got reset. I saw some other time and then it got reset. So I myself is confused a little bit of it. But it's okay. All right. Thank you. So, how will be the future of the healthcare will be? Will it be like this? Will it be symptomatic treatment? No. It will nowhere be symptomatic treatment. The symptoms are you're only allowing it to survive. What we really need to do is the biology driven healthcare. So focus from symptom to systems. So you want to start thinking about, how do I build it? What will be the model that will in India will adopt for digital health? And you can see the multi-omics AI twin models, continuous data collection will become the mandate and priority of our country actually. Can we generate data in a way such that it allows phenotypes to connect, people to connect, and also allows you to do this? To this, we built what I call digital twin models of pathway level dynamics, how one system impacts another, knowledge graph, pathway simulation, and response predictions. And eventually, all data has to be available on your cell phones. That's the only model that will work in our country, because the cell phone has got penetrated in every part of the country as an every individual perspective, actually. Now, many of us work in this area. Now, what you will have to figure out as a scientific person, where do I fit? How do I build one component while optimizing another component? Because if this is what one needs to go, and this will happen. Believe me, there are companies and startups that have already started to do this, actually. And they are all already doing. So for example, this is one of the companies' digital twin that I'm showing you, which is the engineering future of healthcare. Like for example, you have a kind of recurring chronic stress physiology in your body. What do you do with it? Even if doctor is able to identify your chronic stress, you have no way to rechange it back. However, you can measure what you call HPA axis disruption now. What is called hypothalamus pituitary adrenal gland axis is disrupted. How do I correct this axis such that I am able to improve my physiological perspective? If once that happens, you have an oxidative burden in your body, which is like cysteine elevations and impaired glutathione recycling, leads to mitochondrial dysfunction, alters the gut immune axis, and starts to have muscle breakdown. And this is what typically happens when you have a disease of a kind that is chronic in its nature. Now, given what we have now developed over the years, we can measure every aspect of this, correct? We can generate data for every aspect of it by using various models and various activities. What we cannot do is what we really need to do is to develop prescriptions. So, you can see now what will happen is tomorrow's prescriptions will be based on what we are talking about right now, of really putting together all the aspects of disease promulgation, actually. For example, what you call integrative health. It is not about giving medicines. It's also about understanding that how pranayam can downshift your HPA axis activations. You need to get embedded in this our system of methods, actually. Similarly, muscle loss cannot help only by a high leucine diet, but will require low resistance to high resistance exercises depending on your age. So many of these activities, the prescriptions, future prescriptions are likely to be like this right now. And I personally believe that this is where we all need to start playing the game of what I call futuristic goals of how digital twin will engineer the future of healthcare. This is the other model that I wanted to give you, actually, perspective, just to tell you that there are examples in our country that has happened, which are somehow happened through whatever sources, or this is what I call how we should design the tier 2, tier 3 cities, where both you integrate farmers, food, feed, energy, and food and fertilizer together, actually. This is a case of a sugarcane industry. And sugarcane is one of the tropical crop. It's produced in about 4.85 million hectares and 80 tons in hectare. And Maharashtra is one of the key part of it, actually. You can see we are able to use sugar syrup, edible sugar. Molasses is used for 2G ethanol. 1G ethanol is produced from it. The lignin derivatives are going to make chemicals and bioproducts. Fermentation, bio-derived products will make biocompost, pressed mud, soil rejuvenation, agriculture model. And I believe every single tier 2, tier 3 cities will eventually get modeled in this perspective, actually, where a single crop not only provides you energy, which is in the form of ethanol or in the form of higher energy sector, but it also provides fertilizer, also provides food, and also provides sustainability to the soil. Now, if you're from an agriculture background and you're looking at crops, for example, India has so many crops, actually. You look at papaya, you look at, horticulture crop you pick up, or rice, or all these kind of things. You have to develop the integrated picture of it. And these are the kind of solutions that will really change the entire system of how we will grow. So therefore, what government had done is actually announced a BioE3 policy, which cabinet approved by under the Honorable Prime Minister chairship on 24th 2024. And some of you could go and take a look at it. It's really biotechnology for economy, environment, and employment, actually. And to understand this, this is a multi-objective outcome engine of the country. That's a mandate of how we believe the biotechnology will contribute to the country's future. And I won't go into the detailed area of it, but just to give you a few examples, I have another 12 minutes to go. So, what will happen to the energy of the future, actually? Now, if you really look at, let's look at, actually, I gave you an example of health. Now I'm giving you an example of energy. Now, energy systems, right now we import 86% of the oil from the countries, various countries. And you know how Iran and every world is fighting to get an oil. Now we are trying to get it from Venezuela. We're trying to get it from here and there. And this is a chemical refinery, and it produces about 43% petrol, 28% diesel, 10% jet, and 19% other polymers and chemicals. What do we do with this energy chemical sector? How do we really build energy? Because it's another very important idea of this. So this is what we need to do. We need to use recycle the plastic waste of 25%, biomass 25%, and carbon capture technologies 50%. And we will completely get rid of this oil import that we are looking from the other countries actually. And the carbon mass can be in the form of carbon dioxide or from the waste, volatilization waste, or the various activities. And you can see what I've tried to do here is I've said there will be no petrol requirement any longer, because the mobility sector will work on green hydrogen or EV batteries and other kind of activities. Only the heavy engineering sectors will require diesel and jet fuel. Polymers will be 25% and chemicals will be 25% actually. So can we design the next oil refinery for future in this model? Can we design plastics that are recyclable? Because all of you know oil is carbon, plastic is carbon, right? And molecularly, they have a very similar constituent, except the functional properties are different. So they can be interconverted, and there are already technologies emerging from all the sectors to look at it actually. The second part is that if you now change that, what will happen to our chemical industry perspective? Now, our chemical industry is almost contributes 60,000 to 70,000 molecules in this country. 70,000 molecules are produced by chemical industry today. It's a very large industry. 6 to 7% of exports come from this industry. You can look at every part of agro, poultry, chemicals, dyes and pigments, food and feed additive, pharma, construction, water treatment chemicals, home care ingredients, polymer, perfumery, fertilizer, industrial chemicals, paint and coatings and adhesives. You tell me, is there anything that you cannot make biochemically? Almost everything can be produced using biological resources. As of today, our intermediates coming from the petrochemical sector. And once the petrochemical sector goes back, you have to figure out a way of functionality of this. And therefore, you should use the agri-crop, agri-waste, landfill, municipal waste, and industry pollutants to make these molecules. And that's the way you need to design your labs. That's the way you need to design your labs and companies and industries. And that's the future of the country is really. Finally, many of us think that the food is not going to change a lot. And I give you a very recent example of Remilk. I don't know how many of you saw this. This is a tweet by the Embassy of India by Israel. And this Remilk is a company that showcased to the government to our Honorable Prime Minister of how dairy revolution will completely change cow-free milk, cow or buffalo-free milk. You do whey production, and in fact, the whey production scaling happened, I can tell you, in Bangalore, in the Bangalore office and Hyderabad office. And now they are showcasing it in Israel of how this is going on. This is a company called Remilk. Now, why this is important? And again, I said we are the largest producer of milk, but understand the statistics. And this is why science and technology needs to be done at the background of tech data. You look at our milk consumption. We are 25% of the world producer, 230.6 million tons. Human population is about 1376 million, and per capita per person is 459 grams per day. So if every individual has to have a milk today, I only have about 400 ml of milk. Now, to produce this much of milk, look at my poultry count. 303 million bovines, 74 million sheep, 149 million goats, 9 million pigs, and 851 million poultry. Now, who is going to do this? If I ask anybody, do you want to be a veterinarian in your future career? Nobody wants to do it. So who will milk the cows? Who will produce the eggs? Who will produce the sheep? And not only this, there is obviously the scarcity of land, water, antibiotic resistance, cattle, cost of feed, and GHG impact actually. And so if the population is going to be 1.6 billion, you can almost be assured that you will going to have a scarcity of milk again if we don't develop new technologies. Or you develop more buffaloes, or you make buffaloes to milk more and more milk. which we have already tried and brought to a level which is now fairly high in our country. So this is where emerging challenges has to be looked at. If we don't develop science today, the technology of future will come from other countries. And we will follow the same model that we have provided our last few years, that our scientific community do not develop technologies for the requirement of the country's progress, which is where Indian institutions lack the capacity to be able to ensure these activities. And they are very good scientists, very individualistic scientists, but not immensely important for the country's progress. And that's where I'm putting you towards in front of future people of how to really look at it actually. And towards this, what Department of Biotechnology started, we believe, is to engineer right from the PhD era actually, because you can't change people's mind very easily. It's not easy for me to change as well. If somebody tells me, I have to be part of this bigger group and I need to work for somebody else, you can imagine, right? I mean, we all are driven like a PhD student, where we are told like a wolves, finish your PhD degree. This is your work. You are supposed to finish your own work. And this is why we developed this from an individual doctoral training to a network consortia model. And Biotechnology Research Innovation Council consists of all these institutions across the country. And what we have now done is we have put them together done away with the classical model of single student, single PI, single lab, narrow thesis questions, output as publication, to complex biological problems, multi-scale, multidisciplinarity, platform access and cohort data, field linkages, and team science and system exposure. So in fact, every PhD student is mapped on a program. Like for example, direct seeded rice. Why do I have to sow rice in water? Correct? I don't want to sow rice in water any longer. Is there a requirement? Yes, it is a requirement. It's a requirement of the plant, because plant requires anaerobic respiration. The root and shoot has to have a different kind of development growth. Now, every scientist working in different area knows how to do this, but we can't integrate to develop together until unless somebody sets up model like that actually. And that's where our students now are working on a program that are as a project as an individual, but working on a largish program. And we've about identified 50 such programs now across BRIC institutions, and they all work in this kind of problem. Not only this, what we also do is to do away with structural element change, national coursework. They all stay together at one place. So about 75 students stay all together at one place, and then they get distributed to various institutions. So they maintain their own networks, and they're aligning doctoral research with the national goals, and therefore you create a human resource pool that have futuristic working capabilities. And that's the key, because it's the PhD students who drive our country's futuristic goals. And what I call is like convert Vidya to Kala, because I really think there are four facets of learning: Shastra, Tantra, Vidya, and Kala, as our Vedas says. We go very well till Vidya, but post Vidya, we never tell how to convert my Vidya to Kala. That everybody figures out on their own, as I myself did. Can I figure it out how to convert my Vidya to Kala actually? And I think that's where the real challenges are lying. And you can see what these students do for 3 months, and now this is funded by Wellcome Trust for 250 students all across the country. They will go to the social sectors actually for 3 months post their coursework. And this is not directed training. This is training as you learn, as you figure out, because it's the experiences that make individuals and not other way around. So they need to do experiential learning in variety of settings to be able to do what they want to do. And this is amazing. Second batch has now gone there, and we're getting an amazing feedback of how students really enjoy. And of course, there'll be both sides to it, but I think it's a great opportunity for you to do this. So my challenge really is for all of you to motivate and tell you is that why can't we develop BioE3 rural biomanufacturing clusters for our country actually? Why can't we think and design tier 2, tier 3 cities the way we like to do this? And this is how one can put together. You can have a biomanufacturing infrastructure, you can have bioconversion platforms, you can have biological resources, then you can have supply chain, markets and policy, and circular economy actually. And for all of these, each of the projects can be worked out. And in fact, all these students eventually, I want to put it into these systems actually. So can we put them in a pieces of projects that starts to work on, say, papaya, papaya, papain actually, enzyme produced in our country. In fact, in the Maharashtra, there's a large sector. All the papain goes outside the country actually, and it comes repackaged in a higher purified grade format in the country back again. Now that crop is like continuously wasted. You don't know what to do with it, but this is what one can really create. And all of these are kind of an interesting opportunities for all of you to work on. Finally, I'll leave you with one BioE3 challenge that we have announced. And this is a challenge that we have announced for running for an entire year, where you can submit your ideas. And this is an idea because Honorable Prime Minister from the Red Fort said that we have identified BioE3 policy. Why don't all of you be part of this? So this is open for every national, Indian national who can submit an idea for 1,500 words. And you can design BioE3 challenge of any kind that you feel like. And I would like to tell you that this is an opportunity for you to get 1 lakh rupees as a prize. Every 10 prizes we give every month. And then we give 25 lakh rupees for you to take the idea to the POC state as well, actually. So please feel free in any area of activity that we really want to do. Finally, I end you with a poem to just make it a little bit lighter. Pardon me for a Hindi version of this, but some of you who don't understand English, I'll translate. But this is like I was very passionate about buffaloes at one point of time, because I used to work on buffaloes for leukoderma model. Because in leukoderma, buffaloes get spontaneous vitiligo. In fact, elephants and buffaloes are the two animals who get spontaneous vitiligo like humans. And so I started chasing these buffaloes, and eventually we wrote this poem. But this poem sets a lovely settings of how our thinking needs to be reset, actually. And this is भैंस की वथा भैंस की जबान से, and I'll read it for last 1 minute. जब बच्चा जब बड़ा होता, थोड़ा बड़ा होता है, तो दूध मेरा पीता है, वो भी थी बोनमिटा डाल डाल कर, और निबंध लिखने के लिए गाय, हाथी या कुत्ते क्यों. And we have never written on भैंस. We always write on गाय, but no भैंस is written. अगर बच्चा लिख नहीं पाता है तो बोलते हैं काला अक्षर भैंस बराबर, तो क्या दूसरे जानवर पोस्ट ग्रेजुएट है. एंड यदि कोई गलती ना करे तो कहते हैं गई भैंस पानी में, बाकी के जानवर क्या कोको कोला में जाते हैं. And you see, one animal is constantly treated badly, right? And this is how our engagement is about, actually. And then कोई ना सुने तो कहते हैं भैंस के आगे बीन बनाना, तो बाकी के आगे क्या लता मंगेशकर क्या गाना बजाते हैं, क्या बिगाड़ा है मैंने. So you can imagine that there are these animals that are our people, and this kind of branding is the real challenge. That we want to do science, you want to do individualistic science, otherwise it's not a science. And that kind of thought process has to go away. And that's why I tried to put together in English for some of you, since I knew some of you were there. The buffaloes lament in our own voice. It's not easy to do away with traditional thinking. I am the buffalo, dark, slow, familiar to your fields, but the stillness you see in me is not ignorance, it's the weight of your customs. And I believe that's what we are all weighing on, our customs and our thought process and ideas. If you can change the world, this is the way to go about. Thank you very much.
Thank you, Doctor. Thank you for nicely setting the tone for the next 5 days as we get into the granularity of framing a research question, of mentorship and the likes. We can take a couple of questions. The volunteers are here with the mics. You can raise your hands and they will walk over to you with the mic. So we
Thank
have
you,
a question
Professor
there.
Gokhale. That was really nice discussion. This really nice talk. I liked the idea that we as scientists should be working for society. I really like your socialistic way forward. One thing that I was wondering about, I think human nature is not necessarily socialist. So we really want to have our individual contributions, our how is our ego served, which is a lot of our motivation, I think, in science as well. So how will, have you thought about that? I'm sure you have.
I think you're just rightly saying the real problem is that only. But I think I've also realized that once people realize that their successes are aligned together, they then themselves come and aggregate together. I mean, the classical example of milk collection, as I said, nobody will pool things together, because, you say, oh, come on, my milk is better than your milk. But when the systems actually allows you to do that, you're able to do this. But it's very challenging. And that's why I think done at the PhD level is better than at the PI level, because at the PI level, there is even more pressures for you to perform. At PhD level, we have started this activity last couple of years, and there is a really good science for this. But you are right. I mean, very, very important to do that. But I think the governments are also pushing everybody to do that right now, actually, right? I mean, in India at least, and I see in West as well. I mean, for example, in US, the NSF funding is down to 33% of what it is, actually, and that NSF used to fund single PI projects. National Science Foundations, the really area was everybody wanted to have an NSF grant because NSF grant would give you a an independent thought process and activities. And I think they are also doing away with cluster organizations. So I think it will change. It's happening, but it's the most difficult component, as you rightly pointed it out. Thank you.
Thank you. We can take one more question, one last question.
Uh, Excellent talk. My name is Manoj Saxena. I'm from University of London. You have really presented a very good vision that I have also often thought about myself and actually applied to the Bio E3, competition myself. But my question is how, in the vision you said about these PhD projects, so what's the vision, if you can share, to prevent the leak, that the students that you train on these are really like stays in the system, and there are other basically hurdles like age is one of the biggest hurdle, that once they gain experience on certain things, they remain in the system and be part of this for a longer duration, and hurdles like age can be removed on this. Thank you so much.
I think right. I mean, I think there are clearly teething challenges, and I personally think they are teething challenges because of the reason is that the once the ownership comes to them, they will really start to enjoy this partnership. I mean, the data privacy and data perspective is an important aspect, but I think increasingly you can see that if I start doing my PhD and every year I see a publication that has scooped my thought process and ideas, right? What is the use of that? I'm building something and I thought I will complete in 3 years, but somebody has scooped it out in 1.5 years actually, which is becoming very common now. And mind you, the number of publications and number of journals have grown so many that I find it very hard to publish a high profile paper because you need to accumulate 5 to 6 years of work. And this 5 6 years of work, there's always a fear at the back of your mind that somebody will scoop you out actually. So rather, you say aggregator model will actually work. And aggregating this across systems can really provide you a faster approach. And some will buy it, some will not buy it, and I don't necessarily think everybody has to buy the same ideas of it actually. But there are successes that will emerge out of it, will really transform the entire system actually. And I think that is a feasible model. However, the age component that you talked about, in fact, I personally believe that the real challenge in India is the 6 to 7 years PhD that is happening really. The number of years that PhD student is going is taking 6 years, 7 years, and then a postdoctoral fellowship of 4 to 5 years. And then you have almost kind of sugar cane का गन्ने में से जूस पूरा जूस निकाल लिया और उसके बाद अब बोलो कि अपना कैरियर शुरू करो करके. It's almost like that. And we need to be empathetic to that community actually. And I have almost given the word to these students that all of you will finish your PhD in 5 years. And by taking such kind of dramatic decisions, you can really ensure some successes. Because, at the end of the day, the vertical model of success is converted into a horizontal model of success. So everybody can have equal partnerships in it. And I personally think it will work. We have to see. It's a matter of time. How do we look at it actually? But let me tell you, I mean, just before I end my talk, actually, there are about 100 positions in all the BRIC institutions will be available in next 6 months' time across all these institutions in Bangalore, Hyderabad, Delhi and all, and you're all welcome to apply. 100 positions for sure. And I think it's a great opportunity for all of you to grab these positions and as quickly as you can do. However, don't come with individualistic mindsets. That's my only challenge is actually is bring together coherence and systemic level change and thinking. Thank you all of you.
Thank you, Dr. Gokhale.